Hi everyone, I'm Katleen and I run the 4D Oceans Lab here at the Fisheries and Marine Institute of Memorial University. Our project is about understanding the spatio-temporal environmental drivers of subarctic benthic communities. To do so, we plan on using a coastal cable observatory, as well as carry out repeated benthic mapping surveys in Conception Bay, Newfoundland. This project is in collaboration with Ocean Networks Canada, as well as Fisheries and Oceans Canada. I will now turn it over to my two students, Kaitlyn Charmley and Rylan, who are really the driving force behind this project.
Despite moving slower than us, benthic ecosystems are not frozen in time. They're constantly changing and being influenced by a variety of disturbances and processes. However, the impacts of these factors in subarctic seafloor communities are poorly understood. Up here on land, if we didn't understand what was happening throughout the whole range of seasons, you might think trees with these vibrant fall colors all year round. But we know that this doesn't tell the whole story of these ecosystems, and the same applies for benthic ecosystems below the water. We know that these ecosystems are highly seasonal, but with current climate trends, we're running out of time to develop baselines for communities to know what changes are part of normal fluctuations and what changes are likely to alter the ecosystem as a whole. The location chosen for this project is just west of St. John's, Newfoundland and Labrador, in the Holreed arm of Conception Bay. Conception Bay makes a really good reference site for a baseline study like this because it has limited terrestrial runoff and limited human impact. Many species in these ecosystems are not only ecologically important, but are also important economically too. In Newfoundland and Labrador, many people depend on fishing snow crab to pay their bills and put food on the table. Conception Bay is part of the inshore commercial crab fishery. The issue here is that landings have been steadily declining since 2009. Holyrood is also the location for the Smart Atlantic Alliance, where a meteorological and oceanography buoy has been recording environmental data since 2009.
On the west coast of Canada, there are 2 cabled observatory networks and dozens of instrument platforms designed for long-term monitoring. On the east coast, in contrast, we have an incredible opportunity to expand our ocean monitoring capacity. A new cabled observatory will be deployed in Holyrood Inlet this fall. Our goal is to use this new observatory to study the response of benthic megafauna to ocean change over time. Specifically, I'm interested in how seasonal food input to the seafloor influences benthic megafauna. In the spring, we hope to deploy depth-stratified sediment traps near the observatory to measure the composition and sinking rate of the spring phytoplankton bloom and how much organic matter actually ends up on the seafloor. The combination of video imagery, sediment traps, and an in-situ fluorometer will allow us to look at changes in organism abundance, diversity, and behavior in response to the spring bloom. My project will be a starting point as this infrastructure is designed for long-term monitoring. The ocean is changing fast, and primary production will be affected as the global ocean continues to warm, with unknown consequences for the economically and ecologically important seafloor organisms.
And my portion of the project focuses on habitat mapping, which is the use of spatially continuous data sets like temperature and depth to represent and predict biological patterns on the seafloor. They're used to make management decisions and harvesting decisions. The issue here is that majority of habitat maps are built off of only one sampling event. And as discussed earlier, these habitats are not static. So we are building habitat maps off of multiple sampling events in all 4 seasons to assess the influence of abiotic characteristics on the habitat of benthic communities, specifically snow crab, and we're monitoring how these communities change seasonally. Both of these projects will advance our understanding of how spatial and temporal fluctuations structure ecosystems and species of economic importance. It will also help us understand the drivers of shifting ecosystems in the subarctic. Many species assemblages are already shifting their ranges north, so it's important to know the environmental variables that shape these communities so we can manage these ecosystems and predict how they will change due to climate change. Newfoundland and Labrador is only too familiar with ecosystems reaching tipping points undetected, resulting in significant ecosystem changes understood only in hindsight. This fundamentally impacts the livelihoods of the people and communities who depend on these fisheries. Thank you to MEOPAR for the opportunity to speak today. If you'd like to learn more about our project, go to our lab website, www.4d-oceans.com, or you can follow our lab on Twitter @4doceanslab. Thank you.